Hello viewers, welcome to today's session. In this session, we will be discussing about the treatment of solid waste. What are the different technologies available for treating the waste which is generated from various sources like industries, agriculture, hospitals and other commercial places. As you all know that with the increase in the waste generation, the treatment also is becoming very you can say is also becoming very common in this way that all the industries in particular, they are employing some or the other types of their own mechanisms, their own methods by which the solid waste it's treated. So we begin our session with highlighting this point that the treatment and disposal of solid waste is one of the most important concerns for human beings as of today. Because of urbanization, because of so many factors that our lifestyles have changed, the nature, the composition and the quantity of the solid waste has been witnessing a dramatic change. Earlier when we talked about the treatment of the solid waste, the most common method was the burial of the waste. It was buried deep inside the ground and it was considered to be perfectly okay method because at that times the most of the waste was biodegradable. That did not cause any much problem because the waste were put inside the ground after some time slowly and slowly by the action of microbes, by the action of various weather parameters. It was broken down into simpler parts and it just got its own treatment by its own ways. But as we all know, today the composition of the waste has changed. It contains electronic items also, it contains plastics, it contains various hazardous and toxic substances, and therefore to bury it inside the ground may not be a viable option, may not be a suitable option for the treatment of the waste in today's times. So there are different methods of treatment. We will see in this session that how according to the nature of the waste, whether it is agriculture or industrial or radioactive, what different methods can be employed and effectively we can go for the treatment of the waste. Most of the times it involves the action of various physical, chemical, biological factors. It also involves the use of technology. Also in it the manpower, which is the skilled manpower, plays an important role in the treatment of the solid waste. So first of all, I will highlight the importance of aerobic and anaerobic treatment. See learners, there are basically two things in this. One is the aerobic treatment, that means with the help of oxygen we are treating the waste. Means oxygen will allow the growth of microorganisms and side by side the different parameters like temperature, pH, nutrient concentration, they have their own role. But basically the treatment of the solid waste which is most common and which is most easy to use is aerobic and the anaerobic treatment of the solid waste. There are different mechanisms. One is done by oxygen through aerobic bacteria. One happens without oxygen, strictly in the absence of the oxygen, but maybe some other gases are present and different set of microorganisms function in this, that is the anaerobic treatment of the solid waste. So when it comes to aerobic and the anaerobic treatment, further in it there are several sub-treatments, the subtypes you can say. So composting, vermicomposting, as you must have heard about the biogas digesters, that is biogas production. And these are some of the methods by which we can treat the solid waste in with the help of mechanisms which are derived by oxygen or without the oxygen. So let us discuss one by one these methods. First of all, I talk about composting. Very common word. You must have heard about composting. Also, production of compost at your own places where particularly the biodegradable waste is generated. It may be the kitchen waste, it may be the agricultural waste, it may be the horticulture, dairy. These are the main sectors which generate the biodegradable waste. And biodegradable waste, as the name indicates, contain more of biotic constituents. It is easily degraded, it does not have much of the chemicals, it contains moisture, it contains organisms, it contains carbon, it contains hydrogen. So this is the most common means of biodegradable solid waste minimization. What happens is that with the help of the composting process, the waste which is generated from various sources, if it contains more share of the biodegradable substances, composting is the most suitable option, because in this we take the help of microorganisms. They may be bacteria, they may be fungi, they may be protozoa, and by the action of these microorganisms, a black colored substance, which is peat like substance technically if we call it, that is compost, is formed. This compost is very good for the manure purposes. It is a very good fertilizing agent because it contains good amount of nutrients in it. So, how do we define composting? Composting is the transformation, change in the form of biodegradable organic matter. This biodegradable organic matter, if we put it in the broad way, it is all the waste which has been generated from various sources. Even in our kitchen gardens, it is said that we must have composting mechanisms, we must have composters. The compost is the most common method by which the treatment of the, you can say, biodegradable substances can be easily done. Now, another thing which is important in this is composting can occur with oxygen also and without oxygen also. There are two mechanisms. See, first of all, if it is aerobic composting, that means the presence of oxygen is must, lot of oxygen is required. Oxygen helps in aeration, oxygen helps in reducing the temperature, it also helps in removing the moisture content. So, in aerobic composting, the aerobic microorganisms, those which require oxygen for their growth, there are aerobic microorganisms, they react with organic matter, they act on the organic matter and oxidize it. And in turn, the carbon dioxide gas is produced, humus is produced, ammonia is produced and stable organic products are produced, which can be used as a manure. So, it is the most common process because it is happening in the presence of oxygen, and there is no requirement of any particular technological support. You don't need any kind of a special instruments, we don't need any kind of a special arrangement or any other special device for aerobic composting to take place. Similarly, another mechanism is in the absence of oxygen, in the oxygen deficit conditions, if the composting takes place. This is anaerobic composting. Now, what has happened in this, the microorganisms which require oxygen for their growth, they are replaced by the other microorganisms which can function well in the oxygen deficient conditions. So, they are the anaerobic microbes. They do not require oxygen for their growth. So, anaerobic microorganisms here, they act on the organic matter, which is of course the waste products which have been generated from various sources. They take the carbon and nutrients from the organic matter, break down, convert it into simpler parts and release methane, carbon dioxide, hydrogen sulfide. Now, see here, it is because of the presence of hydrogen sulfide that a foul smell comes when this type of composting is occurring in the absence of oxygen, and by the generation of hydrogen sulfide, the foul smell comes, and it is a longer process. It takes more time as compared to the aerobic composting, and here since it is an exothermic process, so a lot of heat is also generated in this process. So, if the foul smell is coming which is very slight, then we must assume that the composting is in process. So, at the end product, when the final compost is being manufactured, the foul smell is very much, the heat is being generated. So, it is a different mechanisms by which. So, it can happen, means those who are involved in the treatment of the solid waste, particularly the biodegradable waste, they can do it in the aerobic or the anaerobic form. So, these are the different types of composting. Next is we must understand that what are the factors which will affect this composting process. Is it that easy because only oxygen, or without oxygen, is it happening automatically? So it is not. There are certain factors which influence the whole process of composting. Number one factor is of course the oxygen, because it is the main determining factor of the release of the end products. As you can see, when the oxygen is present, the carbon dioxide is liberated. But when the oxygen is not present, the methane gas is liberated. The methane is a greenhouse gas that has its own consequences. And oxygen is particularly required for lowering the temperature, as I said. It is required for aeration. It is also required for maintaining the temperature of the particular pile of the waste which we are working on. Another important factor is the nutrient content. See, basically carbon and nitrogen, they are the main nutrients, which are present and which are being considered. So, the approximate ratio of carbon and nitrogen is 30:1 at that time when the composting process has begun. Now, this nutrient and the presence of carbon and nitrogen is very much essential, because the microorganisms which are working, they also need some nutrients, they also need some food to grow and to do their functions. So, when carbon and nitrogen, it has to be approximately 30:1, means 30 carbon and 1 nitrogen, it should be there. But when the composting process is over, while all these type of changes are being taken place in the pile, in the waste products, it lowers down to somewhere around 15:1 or 20:1. So, the presence of carbon and nitrogen also plays a very important role. If the nutrients are not present in the optimum conditions, it will not take place in the manner which we are expecting. Then temperature, as you all know, for working of the microbes, too high temperatures are also not good, too low temperatures are also not good. So, bacteria, fungi, microorganisms which are working, they need an optimum temperature to function. pH values are also very important, because basically for bacteria to function effectively, the pH should range between 6 to 7.5. So, below 6, the functions will be altered. Above 7.5, if it occurs, then there is a release of ammonia, too much of the ammonia is being released, and it also degrades the quality of the compost which we are expecting to be used in our fields. So, pH value also should be appropriate, and the moisture content, because normally what happens is that the biodegradable waste which we are referring to contains high amount of moistures. Because it is organic in nature, it is coming from the biotic sources, it has a moisture content in it. But what happens when the moisture content is very less? If it is too dry, then the whole composting process may take longer time than usual. If there is too much of the moisture, if it is very soggy, if it is very you can say highly watery, you can say, then the aeration is less. So, that also negatively affects the composting process. So, learners, you must remember that when we discuss about the composting, these are the main factors that may aggravate or slow down the composting process, because normally the composting process may take from weeks to months, but all these factors, if they are not in the appropriate amount, appropriate concentration, that they may also affect the whole process of composting. Another important method, very common, you must have heard about, is vermicomposting. Let us first of all differentiate between vermicomposting and vermiculture. What is vermicomposting is that we are utilizing earthworms. It is also anaerobic, it does not require oxygen, it acts upon the organic matter, the earthworms are acting upon, and at the end the treatment of the organic waste takes place. Vermiculture is rearing of the earthworms. When we grow earthworms on a large scale, because we require them for various vermicomposting activities. So, vermicomposting, as I said, it looks similar to composting, but here along with the microbes, the role of earthworm is immense. It is feasible, it is cost effective, it is a biological method for the efficient treatment of the organic waste. So those type of solid waste which contain lot of organic matter in them, particularly the agricultural waste or the industrial waste which contains so much of the organic matter content in them, earthworms are being utilized. The beds of the vermicomposting, you must have seen, and learners, you must remember that vermicomposting takes more than 6 months also. From 3 to 6 months it takes time for the vermicompost to form. You must have seen vermicompost. It is aesthetically better than the compost. It is granular, it is dark colored, and it is very, very rich in nutrients. So when the whole because the process is the same. In the anaerobic conditions, in the absence of oxygen, the microbes are acting upon the organic matter, they act upon them, and at the end, when the end product is formed, it is a well established, granular, aesthetically attractive substance which is highly rich in nutrients, which is encouraged to be used in the fields for more, you can say, plant growth is increased by the application of vermicomposting. So this also is a very effective technique, you can say, for the treatment of the organic waste and for the proper utilization of the organic waste in our fields. And I must tell you something more about the earthworms, that why only earthworms. That type of curiosity should come in your mind, that why we are using earthworms only, why not some other organisms. So learners, earthworms are very, very effective. It is also known as the farmer's friend, and what actually they are doing is that microbes are acting upon the organic matter as they were doing in the composting process also. What is the function of the earthworms? Earthworms are responsible for aerating that whole pile of the organic matter, or you can say the waste substances where we have collected all the biodegradable waste. So individually microbes are only functioning and breaking down the complex into simpler substances, but earthworms are creating more space, they are increasing the distance between the pores, they are responsible for bringing in more aeration, more you can say more mixing. Actually that type of thing is done by the earthworms. So there are different species of the earthworms which are being used all over the world, and selection of which earthworm species which we are using for vermicomposting, that depends, that it should have a wide range of environmental factors tolerance, it should be easy to grow, it should be easy to culture, it should have a high feeding rate. So these are some of the important characteristics of the earthworms which are taken into consideration while we devise the vermicomposting for the treatment of the organic waste. Another important factor under aerobic and the anaerobic is biogas generation. You must be knowing about the biogas. It contains methane, and in the marshy areas where a lot of what should I say, a lot of soggy conditions are there, in the mangroves and in the bottom of the water bodies, we say that the methane is generated because organic matter there is being acted upon by the microbes and leads to the generation of along with carbon dioxide and many other gases. So that is why we say that methane is generated from our paddy fields also, methane is generated from the swampy marshy areas also. So actually you must have heard about the biogas generators or digesters, which are compact structures where the organic matter is fed inside, airtight containers are there, no oxygen is present, and therefore by the action of the microbes and the nutrients which we are providing, the generation of the methane takes place, and also the other gases which can be utilized for other purposes. So normally biogas generation is a naturally process, it occurs in various ecosystems, it occurs in nature, and therefore it is a main worry and one of the main source of the emission of the greenhouse gases into the atmosphere. So it has certain steps in it, you know, these are anaerobic digestion taking place. So there are steps like hydrolysis occurring, the complex substances breaking down into simpler ones, formation of the acid, because acid forming bacteria, they now act on the simpler organic substances which were one complex, they were broken down into hydrolysis. Acidogenesis takes place, like acid is formed, acetate is formed in the next state because acetic acid, and then the methanogenesis occurs, like generation of the methane. So all these different steps, you know, they have been affected by different factors like the pH, the temperature, the moisture content, the size of the pile. All these are very important factors which affect all these processes which occur under anaerobic digestion systems. And there are environmental conditions also. See, as I said, it takes too much of time for the treatment of the organic matter through these mechanisms. So, retention time of the pile of the waste which has collected plays an important role for how long the waste is retained in those chambers, in those closed containers. If the retention time is large, the process may take longer time to complete. Oxygen normally is not required, it should not be there, so it is a limiting factor. The presence of oxygen may alter the functioning of these digesters, so there should be no oxygen present. The pH value should be optimum between 6 to 7. If it is acidic more than below the 6 pH value, it will not be able to function effectively. Carbon nitrogen value, that is the fixed ratio, as we have said that it should be 30:1 is the ideal carbon nitrogen value. But if it is altered by the application of certain nutrients from outside, if it is not proper, if the nitrogen content is more, it will lead to the emission of ammonia, it will lead to the formation of the other gases, and it will affect the whole methanogenesis and acetogenesis stages. So, optimum carbon nitrogen value is also very essential, which affects the working of the digesters. So, after seeing what are the aerobic and the anaerobic treatment mechanisms, let us now talk about another category of the solid waste which is also very important, and that is the hazardous waste. The waste which are generated from industries, maybe from the nuclear power plants, thermal power plants, they are very hazardous. We cannot deal with them casually. We cannot leave them outside and open. We cannot throw them in the water bodies. We need to devise some proper mechanisms by which the hazardous waste can be treated. So, there are physical methods, chemical methods, biological methods, thermal methods by which we can use to reduce the effect of these hazardous waste. Learners, you must remember that whatever the treatment mechanisms we are talking now, they are just like a pre-treatment. They are not acting upon the hazardous waste, but before landfilling them, before incinerating them, some treatment must be done so that their hazardous nature can be reduced, the toxicity can be reduced. So, number one, let us discuss about the physical treatments which employ various mechanisms physically. So, see, filtration is most common method. What is happening to the hazardous substance is that by small processes, we treat these hazardous substances so that their bulk or their quantity is reduced. Once their quantity is reduced, the transportation cost is lowered down. The factors which are responsible for the treatment, they can be individually taken off. So, this way the physical treatment works, like dewatering, especially for the treatment of the liquid waste. The dewatering is very effective. By the application of the water, by flowing water, most of the substances which can be flown away, they are removed, and what is left behind is the colloidal substances, which the harder substances which we have to take care. Then encapsulation. What happens in encapsulation is that, you must have seen in the treatment certain structures, which are waterproof, which are made up of chemically inactive substances. They are formed, and in that we are putting the hazardous substances, chemicals, so that they do not react with the outside environment. In certain cases, lime is mixed to form a cement-like structure so that it is non-reactive. So, these are physical mechanisms. Likewise, sedimentation is also done, coagulation, flocculation, adsorption, distillation, evaporation. All these mechanisms involve the usage of the water or some other methods by which the bulk of the hazardous substances is lowered down so that there is less substance to be landfilled or to be incinerated. Likewise, we have the chemical treatment done to these hazardous substances. You must have heard about the acid-base neutralization. Acidic medium and the alkali medium, they react with each other, and so there is a neutralization reaction taking place. For example, if the industrial waste contains more of sulfuric acid in it, so it can be acted upon by sodium hydroxide so that it is neutralized. Similarly, oxidation and the reduction treatment is also very common. We use hydrogen peroxide for oxidizing, and by virtue of the application of these chemicals, the nature of the hazardous substances is changed, it becomes less toxic, and then we can further use it, or we can further treat it in a different manner. Similarly, precipitation, you must have heard about the precipitation methods. For example, if the waste, they are containing hydrogen sulfide or such type of, which by the application of certain catalyst, if the precipitates are formed, they settle down at the bottom and then they can be removed. Similarly, metals are used for the ion exchange method, which are with the help of cathodes, anodes, the ion exchange can be facilitated, and by this, with the use of the chemicals, the toxicity of the hazardous substances may be minimized. Then we have the biological treatment, where the biodegradable waste can be treated with the help of biological treatments. Bioremediation is the most commonly used biological treatment, and the effectiveness of this method will depend again on the activity of the microbes. How active they are, what is the nature, what are the other deciding factors responsible for treating the waste in a proper manner. Then there are thermal treatments which involve the application of high temperatures and pressures. Incineration is very common. We heat the lot of temperature is being applied, and the waste is reduced in volume by 60 to 80%. Pyrolysis method is also used, where in the absence of oxygen but the presence of inert gases is there, and the hazardous substances are converted into less hazardous ones, and normally the bulk of the waste substances is reduced. Then plasma arc is a mechanism by which, with the help of electricity, we are using the electricity and also high temperature and pressure to act upon the hazardous substances which are collected in bulk, and they are now converted into less hazardous ones, which can be further treated through any other mechanisms. Like vitrification involves formation of a glass like structures are found when by the action of certain chemicals on the hazardous substances, a glass like structures are formed which are comparatively less harmful, which are less damaging to the environment. So these are all engineering and technical methods which are used in the industries on a small scale or a large scale by different methods, and depending upon the nature of the hazardous waste, we are using these technologies. For example, for the waste which is generated from the nuclear power plants, the technologies may be different. For slightly hazardous waste which is being generated from the industries, a different method, simple incineration or pyrolysis, may also work in such cases. Then another important category of the solid waste is biomedical waste. Generated the waste which is generated from hospitals, healthcare centers, that is also very toxic, that contains harmful substances, and if it comes in the contact of human beings or the nature, it may pose several problems. So certain mechanisms are there for the treatment of the biomedical waste. Some of them are autoclaving, incineration, thermal inactivation, chemical disinfection, microwaving, irradiative process, shedding, reburial. This, in some way or the other, they either use the temperature or the pressure or some agent to reduce the toxicity, to reduce their volume, and also may be used in a small scale and the large scale. So many of the hospital premises, they have their own autoclaving machines, they have their own incinerations for sterilizing the equipments, for also treating the waste which is coming out, human samples, you can say, such type of toxic substances. So according to our own, because some methods are very cheap, Some are very expensive, we cannot use it on a small scale. So depending upon the quantity of the waste which is being generated, the nature of the waste that it contains, which category does it fall in of the biomedical waste, then accordingly the treatment mechanism is devised. For example, incineration, again as we have seen, it is high temperature burning so that the waste is reduced to ash. Thermal inactivation again involves lot of temperature and pressure so that the activity or the nature of the biomedical waste is altered. Microwave is again use of the UV rays. So they break down the bonds between the waste materials. Similarly, we have the treatment of the electronic waste in the same manner, which contains the harmful substances at different levels. The electronic waste is being treated. It contains the hazardous substances also and the non-hazardous substances also. On the basis of the nature of these substances, the appropriate technology is utilized. So with this, we conclude that mishandling of these solid waste degrades the environment. Treatment is very essential because it reduces the volume, it changes the forms, and it makes it easier to handle, and a combination of the methods which we have used can be utilized for the effective treatment of the solid waste. Thank you.